Alright guys, so we're here doing a gasket change on this RTAA screw. We've already got, so we isolated just the compressor on its own. We've got the discharge pulled up out of the way. We're going to be taking this whole assembly apart, changing the O-rings and the gaskets. You can see that there's one of the front covers there. Getting all this cleaned up, getting it back together. You can see right there, there's a bunch of service marks where people have definitely worked on this and before. This compressor's had a lot of service done. I see a lot of pitting here on this slide valve, but it moves very, very smoothly. It's not sticking on us, so I'm not too worried about it. It wasn't having issues loading or unloading prior to this. So anyway, the complaint here was just this whole discharge assembly was leaking. That's a very common issue to have when you get aged screws, is the discharge assemblies don't hold up. Doesn't matter if it's Train brand, Carlisle, I mean, just across the board. I see it just about every day. There's constantly something we're riding up, so they decided they want to go ahead and fix it, so we're going to fix it. Alright guys, so we got the housing apart. Right now we're getting in here, cleaning this up. Then once we do that, we'll be able to slide the O-ring, the new one, back in and get it reseated. We'll put a little bit of nylog on there to help give it an extra seal, give it some longevity, and then we'll slide the bolt housing back together, bolt her up, and keep on moving. So that's a wrap, guys. We got the whole discharge assembly. So in the end, we replaced this O-ring in here, replaced this gasket on this front plate, and replaced the discharge O-ring all together. We also replaced the relief valve. It was leaking. This compressor had was leaking oil from around this seal real bad. So we'll have to add some oil back to it. We're going to change the oil filters, take care of that, and then the customer is going to supply some refrigerant to make up whatever was lost through the leaks, and we'll get this thing back online. So I hope you guys enjoyed it, and I'll catch you on the next one. Working on this roof today. They had a bunch of penthouses. There's a big fire panel change out going on at this facility, and they had several air handlers during the commissioning that were not tripping on the fire system, even though, so that what they do is they trigger the smoke alarm and the ducted smoke detector, and they make sure that it would actually shut the equipment down. They had a few that were not actually doing that, so they called us in to, so we do the automation here, so I'm here on automation call taking care of this. It had something like 6 or 7 air handlers that were having trouble. I've got all of them but one so far working. Had several wiring issues during the retrofits that it has had where it wasn't tied back in properly. We had some that the air handler wasn't functioning properly due to some VFD issues, which all ties back into the automation. And then I had one where the drives the drives on the air handlers were left in hand, and because they were left in hand, they it was ignoring the fire emergency stop because of the way it's wired in, which is a whole nother issue I'm not even going to get into right now. We really need to go through and redo a lot of the emergency wiring on this whole building, but we're working with that out with the customer now. And then this last one I'm on, got here and one of the control fuses was blown. I went through, checked the system, didn't see anything immediately a problem. I didn't find any immediate shorts or anything else, so I'm gonna replace the fuses. Had to go pick some up, and we're gonna re-enable this thing. Let's see if we can. Look at there, work like a charm. Yeah. So anyway, it was calling for it through the EMS. It just wasn't running. See, we're in auto. So now what I need to do is I need to verify that the fire, when it trips, is actually going to shut the air handler down so they can get their commissioning test. So you can see our duct detector up here. Oh, this is one of the remote detectors. It goes to a different detector, so I'm thinking it's got to be that outside air. So we're going to come back down. So some of these were set up to where I'm not overly versed on fire systems, but just from what I've seen of the way this is laid out, they have 2 or 3 detectors tied into one main, and so that one is also a remote with the way it's set up. Let me see if I can find the master one. This is interesting. First time I ran into this. So it goes up, down, over, back to the air handler we were just working on. And it comes back this way. We hit that one there. We could go a couple of directions from there. What I'm wondering is, does it tie into this one? I see air handler 7 is not running. My understanding is they're all supposed to be. I have not verified on the front end on the computer. Fan stop start. This panel here. I do not see a smoke anywhere though. That's the thing. Oh, here we go. Walked right by it. Alright, so when I see these, what I'm discovering is this is some kind of remote control where it can tie into multiple other heads remotely and control them. And so that comes over and down and hits that conduit there and back over. Man, this is just... I don't have any schematics of any of this stuff either, so I'm just having to trace and look and find and figure out, and yeah. I don't even see a motor starter for this air handler. Oh, I got a VFD right here. There's no display. Lights are off too. This thing looks, heck, it looks like it's been decommissioned. It's weird. Well, so we got this air handler on. It was just a control fuse. No idea as to what actually caused it. So I'm going to see. Can't tell by looking in there what wires are landed, but with what I've seen so far, what that tells me there is those are tied into one of these. Now I need to find out which one they're tied into so I can open it and make sure that that air handler shuts down like it's supposed to. Which there may be an easier way now that I sit here and actually talk about it with you. And this is just my process. I'm actually just kind of openly showing you kind of just the thought process I go through, what I look at, what I'm looking for. I'm not going to drag this out much longer just because I don't want it to get boring, but this is what I do every day. Every day. It's our controller here. Shower, chill water, fan status. Yeah. Alright, let me go through this and I'll give you some updates. I'll take you to some of the other mechanicals and show you around. Alright, and so I found it. So what I'm doing, your automation's calling for it. I trace out the fire shutdown circuit on the controls, and this is where it came to. These two blue wires are from the automation. There's red wires from the fire detectors. And then, I don't know if you're gonna hear this, but that's what I'm looking for right there. So, if this fire system trips, I know that's gonna shut down. What this tells me is this unit wasn't working because of the fuses blown in the starter panel. No indication as to why they blew. Everything checked out fine. Put the new fuses in, worked perfect. So that's a separate issue all on its own. But anyway, this unit is shutting down now. So part of what happened was some of these would not run. And so because they could not make it run and personally verify that it was actually going to shut down, they had to write them up as not working because the air handler itself didn't work, not because the fire system didn't work. Anyway, hope that makes sense. This is a wrap. Like I said, I'll take it to the other penthouse. I had, I think, 6 of them in there. I had to fix different issues, and we'll move on. So this is the other mechanical room, the one I had the most trouble with. This air handler here ended up having an issue with just some loose connections up through here, so we got that addressed. It's now firing correctly. This one here, there was a wiring issue where it was not killing the drive over there in the corner, and then the high static had tripped, and again it was bypassed, and so got that resolved, but that was why it wasn't shutting down. This unit here, they wasn't running. They just didn't have it on, and so they just, instead of getting it to turn on, they ended up condemning it. I got it functional, and so confirmed that there. And this VFD here was in hand, and because of the way it was wired, it allowed it to bypass the safety, which was preventing the air handler from shutting down, even though the fire tripped. So redid all of that, got it working properly now. So every time it loses the fire contacts, it kills the whole system. And yeah, I mean, the hardest part about all this is, you know, I don't work with fire systems very often at all. And so trying to go through and see how they laid it out, what they've done. This is actually my first time to see the remote little controllers there like that. I've never ran into that before until this, so that was a learning curve there. You can see this one. So this one is remote connected to this one here, and so anyway, it's just it's different, you know. At the end of the day, that's all it is. It's just different, something I hadn't actually ran into, but you know, it's part of keeping up with the trade, guys. You know, things are going to change, things are going to develop, they're going to come out with new stuff, and you got to be able to figure it out and adapt. Anyway, checking out on this one, off to the next. Well, we're back here again at this train we've been working on. It's a CVHF. See, it's only got a 2-stage compressor. Anyway, I just wanted to do a final follow-up. I still have to do the actual PMs on this chiller, but the service call aspect of it is completed. I figured you guys may enjoy just a final follow-up on it. So, what it came down to was, you know, I spoke about that discharge sensor. It was out of range. It was reading about 15 degrees off. Got that changed, and that really helped our purge assembly in finding that temperature, and it worked up to a certain point, but the purge only purged so much. I could tell by my readings I still had a lot of atmosphere in there, but the purge just wasn't seeing it. And so it really made me start to question the suction sensor on the purge. So what this purge does is it's monitoring the suction temp here on the suction line, and then it has a liquid temp reference. Well, we don't have a physical liquid temperature sensor on this purge assembly, so what we're using instead is, when it's running the condenser saturation, which is where that sensor really plays a big role. The condenser saturation is our liquid temperature that the purge sees during operation, and when it's in the off cycle, it looks at the evaporator saturation sensor. And keep in mind, so these trains, they rarely do I ever see them with actual transducers on the barrels. What they use these temperature sensors for saturation. They have one there on the discharge, or on the condenser, I should say, and then there's one down here on the evaporator, and that is what it's using to actually determine what the system pressure and operating status is. And so it takes that temperature and then converts that temperature into a pressure instead of vice versa. So that's just something you know, you see on these this train, CVHE, CVHFs, you know, specifically. I know they do it on other models as well. So anyway, so it takes that saturation temp, and then it uses that in comparison to the suction temp, and it wants those temperatures to be so far apart. It wants this suction temperature to be I believe it's between 50 to 60 degrees below the saturation or the liquid temp for the refrigerant. When it registers that, it knows that it has the purge assembly is full of atmosphere, and it needs to purge out on a pump out. And so anyway, it wasn't going through that cycle. It was close. It was just a few degrees off from needing to go into a pump out, but it would stay there. And sure enough, I pulled the now all this had a bunch of old grimy insulation on it, and on the back side, let me see if I can get a shot of it. So on the back side down there, right there where that old insulation starts, there is a little threadlet port that the sensor actually threads into. Well, somebody had replaced this sensor at some point in the past, and they broke the old sensor off in the threads. And so instead of, fixing it, what they did was they just zip tied the new sensor straight to the suction pipe. The problem with that is that sensor is actually, you've got the body of the sensor itself, we'll say is this part of my finger, and the very tip of the sensor is the thread, and it's significantly smaller than the main part of the body. Well, the actual sensing element is in the tip of those threads. So what they had was the body was making surface contact, but the tip wasn't. It was just reading air relative to the pipe. And it wasn't very well insulated either to begin with. So what that did is that made it read, a good 10, 15, sometimes 20 degrees off from the actual suction pipe temperature. So it never knew that it needed to purge because the algorithm that does that wasn't getting accurate readings. Anyway, tore all that apart, ripped all the old insulation off, and then I wasn't able to get those threads cleaned up in there to where I could thread the sensor in like it's supposed to be. So what I did was, where that tip is, I put a zip tie on that tip, which made that sensor kind of sit at an angle intentionally, so that the tip where the sensor is actually made surface contact with the pipe. And then I just put a secondary zip tie further up, not tight, just enough to kind of help hold it steady, and then re-insulated it really well with some cork tape. Probably overdid it more than I needed to, but I wanted this thing to really work well. And immediately upon doing that, it saw that suction temp take a dive and it started doing exactly what it needed to. And after that, it had to pump out for a solid 24 hours after that. And that was it. It pumped out overnight and part of the next day. And by the time I came and checked it that afternoon, well, it hadn't needed a purge since. It's been perfectly fine. This chiller stopped all surging. I've been able to go into a full, raise the full load current to 100%, and this thing's been working like a dream since. And so, again, this is what I'm talking about when, poor service, poor maintenance, people just either not understanding or not putting in the effort needed to really do this stuff right. And it builds into this one big, huge issue. I mean, it's crazy just what you find and run into in a situation like this. This chiller had been condemned. They were telling them they needed all this kind of crazy stuff and needed all these teardowns, this, that, the other. I'm sorry, but they were wrong. What it needed was the sensors and the system to be set back to a functional state to where it could work like it's supposed to, and then just do its job, which is what it ended up doing. It has so much atmosphere in there. It sat idle for years and years and never even ran because of this stuff, and that allowed just even more atmosphere and things to get in. I'm not too worried about leaks just because I haven't had to purge. If I came in, it's been 3 days now since all this happened. I'm kind of late getting this video taken, but I haven't had to purge in 3 days, not even once, not for a second. So that's incredible. That's exactly what I want to see. So because of that, I'm not overly worried about leaks, because if I had some serious leaks, I wouldn't be able to go that much time between purges, or pump outs, I should say. And another bonus is by fixing everything and getting it right. Now, those BBs are stuck in the bottom, but you're not going to be able to see it with this camera. But when I first got here, our oil level was down to about right in here. It was down pretty low. It was so low. I was worried about even running it with it the way it was. The customer went ahead and approved adding 5 gallons, so I did, and that got me to right in just the bottom of the sight glass, and I was okay with at least putting it in operation at that point. Went through. I did find one of the oil valves back there was closed, and that's one of our oil returns. And so anyway, this thing has had a solid 3-4 days now of really good operation. They've been running it 24/7, and all of that oil migrated back. Our oil level is actually just above the upper sight glass. I mean, just barely above it. I'm really happy with that. I'm happy with where we're at. We got all of our, so it confirmed that it confirmed that the oil had migrated, which means that we made the right choice by not assuming that all of it had been removed from the system and that it was just somewhere else in the system. So all that oil's been returned back to the sump. We look really good. It was probably a little low on oil to begin with, or I think that 5 gallons, that definitely helped it for sure. And so yeah, right now it's down on set point. They're just waiting for that water temp to come back. This building has some load, but it's not a real heavy load right now, so it is cycling. So yeah, this is what I'm talking about, folks. This is what I'm trying to educate people and tell you about is, this piece of equipment here, before we got here, was basically nothing more than scrap metal. It had a starter coil going out, it had purge issues out the wazoo, oil issues, sensors, I mean, just all kinds of stuff. It had not had very good maintenance. I mean, heck, the purge filter that it had sitting on the purge had a factory date code of 2014. You can see right there, this is June of 20. And so anyway, that just tells you what little maintenance and work and things had actually gone into this chiller. So it's extremely rewarding to put so much work into it. I think I spent 2 or 3 solid days just plugging away at this thing little bit by little bit, making a correction, letting it run, seeing how it responded, trying to let the purge catch up, make some more corrections, and so forth and so forth. And this chiller is still not 100% out of the woodwork. There's still some automation issues. There's still some other minor things. But where we are at is this thing is 100% operational and savable. And there is no need to do any kind of major anything other than just make it right. So that's it, guys. I wanted to give you an update. And we got 5 more to go.